Welcome back. Let's talk about molality. Like we talked about in previous lectures, percentage and the mole fraction, molality is also a unit to express the concentration of solution. Now, molality of a solution is defined as the number of moles of solute dissolved in 1 kilogram of solvent. That is, molality is equal to moles of solute divided by mass of solvent in kilograms. So we can write it in this way also. Nb is the moles of solute divided by Wa, that is the mass or weight of solvent in kilograms. Now, taking the mass or weight of solvent in grams, we need to multiply the expression by 1000. So we have molality equal to this. Now, as we know, number of moles of solute is equal to mass or weight of solute divided by molecular mass of solute. So we can rearrange this expression as, so molality will be equal to Wb by Mb into Wa in grams multiply 1000. This is the required expression for molality. Now, for a solution, if molality is equal to 1, then it's called as a molal solution. Similarly, if it's 0.1, that's 1 by 10, it's a decimolal solution. For 0.01, it'll be a centimolal solution. And if molality is equal to 0.5, it'll be a hemimolal solution. Now, for a molal solution, that's molality equal to 1, this would mean that 1 mole of solute is present in 1 kilogram of solvent. Therefore, we can find the moles of solute and the mass of solvent. Here in this case, the moles of solute will be 1 and mass of solvent will be 1 kilograms or 1000 grams. Let's illustrate this with certain examples. So we have the first illustration. If 40 grams of calcium carbonate are dissolved in 2 kilograms of water, then find the molality of solution. As we know, molality is equal to the number of moles of calcium carbonate divided by mass of water in kilograms. Mass or weight of solvent is given as 2 kilograms. We need to find the moles of calcium carbonate, for which the mass of calcium carbonate is given as 40 grams. Therefore, moles of calcium carbonate will be equal to 40 by 100 because 100 is the molecular mass of calcium carbonate, and that boils down to 0.4. So the moles of calcium carbonate is equal to 0.4. While putting the value in the expression, we can get molality equal to 0.4 by 2. That gives us the molality of solution equal to 0.2. Similarly, we have the next illustration which says find the molality of a 20% urea solution. So we have a 20% urea solution from which we can clearly get the mass of urea equal to 20 grams. Mass of solution will be equal to 100 grams. On subtracting the two, therefore, we can find the mass of solvent equal to 100 minus 20. That comes out to be 80 grams. From the mass of urea, we can find the moles of urea equal to 20 by 60 because 60 is the molecular mass of urea, and that gives us the number of moles of urea equal to 0.33. While putting the values in the expression of molality, we can get 0.33 by 80 multiply 1000, and that gives us the molality of solution equal to 4.16. So we can say 20% urea solution will have a molality of 4.16 or will be a 4.16 molal solution. In the same way, we have the next illustration which tells us find the molecular weight of a compound whose 20 grams are dissolved in 100 kilograms of water to prepare a decimolal solution. So in this case, we need to find the molecular weight. Now, we are given with the mass of compound equal to 20 grams, mass of solvent equal to 100 kilograms. Molality is equal to a decimolal solution, that's 0.1. Therefore, we can use the expression of molality that's equal to WC divided by MC into WS in kilograms, where WC is the weight or mass of compound, MC is the molecular mass of that compound, WS is the weight or mass of solvent. While rearranging the expression, we can find the molecular weight of compound equal to WC divided by molality into WS. While putting the values, we can get 20 by 0.1 into 100, and that boils down to 2. So the molecular weight or molecular mass of that compound is 2, which says the compound is expected to be a hydrogen gas. I hope you understand this. Now I'm asking you to find the molality of an aqueous urea solution wherein the mole fraction of urea is 0.5. Once you finish up, please write the answers in the comments. Till then, take good care of yourselves. Thank you.